Traditional UI automation often involves fighting with fragile test suites, manual sleep commands, and race conditions that cause random, untraceable failures. To solve this, we are going to take a completely empty folder and turn it into a recorded, multi-browser testing framework in just a few minutes. Playwright runs as a separate Node.js process and communicates directly with the browser engine, bypassing the translation layers that slow down older tools. This direct connection eliminates the latency and communication errors inherent in middleman drivers, standardizing UI automation as a predictable engineering practice. Your baseline requirements are simple: a standard operating system, an internet connection, Visual Studio Code, and Node.js. When installing Node.js, ensure you check the box to add the software to your system path. Failing this is a common error that blocks your terminal from recognizing Playwright commands. Once installed, open the integrated terminal in Visual Studio Code and initialize your environment by running npm init playwright at latest. The generated playwright.config.ts file is your system's control center. The project's array configuration is already set to test against Chromium, Firefox, and Webkit simultaneously. This single command automates the driver and browser configuration, providing a standardized project scaffold that is ready for immediate development. You can generate your first script using the CodeGen tool. As you click through a web page, this tool records your interactions and writes the corresponding locators in real time. When specifying a URL, you must include the HTTP/HTTPS prefix. Without this protocol, the test will immediately fail. In JavaScript, test steps are asynchronous. You must include the await keyword before your actions to ensure they execute in the correct order. Playwright manages timing through auto-waiting. As seen here, the framework pauses the test until a button reaches an actionable state, meaning it is visible and stable, before executing the click. By resolving race conditions at the framework level, auto-waiting removes the need for arbitrary sleep commands and addresses the primary cause of test flakiness. To run the script you just generated, enter the command npx playwright test. Each test runs inside a browser context, an isolated environment created instantaneously. This allows the same script to run simultaneously across Chromium, Firefox, and Webkit without sharing cookies or leaking data. Your terminal will show these worker threads actively running in parallel. Combining isolated contacts with parallel execution significantly increases QA velocity, turning hours of sequential cross-browser checks into seconds. To test the reporting system, intentionally change an assertion in your code to trigger a predictable failure. Run the test again, then serve your local dashboard by running npx playwright show report. By clicking on the failed test in the report, you can enter the trace viewer, a dedicated environment for investigating failed test runs. This allows you to inspect the exact state of the page at the millisecond of failure. You can view the before snapshot to see the page state, then check the after snapshot to see how the application responded. This level of visual evidence resolves the guesswork associated with CI/CD pipeline failures by revealing exactly what the browser experienced. You have now transitioned from an empty directory to a recorded multi-browser test suite with built-in reporting. Your next step is to explore advanced features, such as intercepting and mocking network API calls to isolate UI behavior from backend instability. Standardizing on Playwright shifts the engineering effort from maintaining testing infrastructure to verifying the reliability of specific user workflows.